Okay, thank you very much. I've seen a few of you over the last couple of days and just obviously wanted to run through from my perspective. Obviously I work for a hardware manufacturer, we also obviously do the associated software, but more so from the involvement I've had with government working groups and also as being a chartered surveyor. So I'm going to do a very quick sort of run through. I normally do this presentation over about half an hour, so we're going to try and condense it down a little bit. So who I am for a start. So I work for Leica Geosystems as a laser scanning on the laser scanning team. I've only been with Leica for just over a year now, but I have, however, got the industry experience of working as a chartered surveyor, but I have been involved obviously with point clouds going back quite a few years now. My current industry involvement is I work with the TSA, which is the Survey Association. I sit on their technical committee, so we do client guidance notes, specification, briefing notes on the various movements forward within surveying. So SUAs was one of the least recent ones we do. Laser scanning, setting out, so any sort of typical. And they are guidance notes put there in the public domain for you guys to obviously read and work with. I'm Associate Assessor for the RICS, so having hopefully a positive effect on formal qualifications for obviously future surveyors moving through the ranks. And I've also, as I said, been working with David Philp on the government working group for laser scanning specifically. So Leica Geosystems, I'm going to start with our main parent company first. So for those of you who don't know who Leica Geosystems are, we belong to part of Hexagon Group, which is a 2.2 billion euro turnover establishment, a Swedish company with a focus around measurement technology. We are one of many that belong to the Hexagon Group. Intergraph you may have heard of. A few people in the audience may also have heard of a company called TechnoDigit, which have a lovely piece of meshing software called 3D Reshaper. But Leica Geosystems we class ourselves as measurement providers. We produce both hardware and software to form solutions within the construction process. So be that from initial design and data capture through to obviously setting out construction process moving forward. So we've got various bits of technology which obviously enable us to work within the BIM process. Single point measurements, total stations, hopefully many of you will be familiar with obviously the total station form. Construction, setting out, GPS receivers, machine control, agriculture, wide range of disciplines that we do obviously operate in. Interior fit out, 3D distos, handheld laser distance measurement, all tools that are used actively within data capture and obviously construction process. And on to laser scanning. So laser scanning is really where my sort of heritage is and my background is. And laser scanning really is one of the, what we're seeing within our market sector is very much the growth area. So the history of laser scanning as far as Leica Geosystems, we were one of the origins of laser scanning technology. Back in 1998, Leica Geosystems acquired a company called CITA Technologies, and we've taken technology forward over the years from 1,000 points a second up to where we are today, which is 1 million points a second. 360 data capture, very, very rapid. So the scanners that we run today, I've got one here, and I'm actually going to do a little bit of a live breakout session at the moment. So the P20 is our 1 million points a second, so very, very steep development curve that we've taken on over the last 10 years of technology. I'm going to set this very quickly scanning. So I'm going to do a 58-second scan of the room. I've already done some data capture already in the room, which we'll have a look at. But I think the big thing that I want to try and put across is the value of having data and having the data at appropriate times during the project. I think on a blank canvas development, BIM and what we're trying to achieve from BIM is absolutely fantastic, but we're all hopefully of the opinion that building into an existing scenario is far more common to what we're actually seeing these days. So having an accurate representation of the site before we start doing design work and development work moving forward is really, really critical. And I think it's one of these things that for a long time as a surveyor and having been asked to produce survey data, we almost get involved at a very sort of a late stage in the day. There's already been development work, there's already done pre-procurement's already gone through potentially. And delivering accurate data is something that actually is sort of lost along the way, and it's always sort of delivered as a lastminute.com. And I think where surveying community fits into the BIM process is that we can actually get involved at an earlier stage and produce better deliverables for our clients. So scanner has captured. Let's just get this data off. Okay, let's set that, getting the data off. So I think certainly from my point of view, that where we do sit as surveyors is having an input into capturing of this data. We've got the hardware, we've got the software these days. Just a quick hand show, how many people in the room are actually actively working with point cloud data? Few, okay, that's good, that's good. I've stood in a room where we've had 2 of 114, which is kind of great because it's very much a blank canvas to work with. But I think having the value of the data up front is really, really important. So I'm just going to break out of the presentation a little bit. Okay. And get this data off. And I think what I want to show is how quick we can actually start working with the data. So our program is Cyclone. Get this importing in. Okay, let's get this data going in and then quickly nip back to the presentation. Okay, so where we start to see strength in the industry is working with point cloud data. So data is data. Hardware manufacturers, there's a few of us here today. We obviously sit with having a solution. So we start with obviously with the data capture element. We move through into what we do with the data. So we have our proprietary software, which I've just started importing the data into, which is Cyclone. But where we come into strength is obviously having plugins for third-party manufacturers. So we have plugins for Autodesk products. So Autocad, Revit, Studio Max, Maya, also the Bentley suite as well. So we've been working with point cloud since, as I said, late end of the 1990s. Point cloud engines natively within Autocad or Autodesk and Bentley products are something of a very, very recent occurrence. We've been enabling the use of point cloud data certainly within people's native drafting packages, because it's far easier for you guys to actually work within a program that you're comfortable with and that you know, rather than actually trying to teach old dogs new tricks sort of thing by teaching you how to use all these tools inside Cyclone. We've got accessible data formats, so we've got a package called Leica TrueView, which enables you to view point cloud data in an Internet Explorer environment. Very, very good for sharing of data and obviously making it understandable and making it usable for the non-technical person. So, everyone runs Internet Explorer, so let's give you the ability to take measurements, query dimensions, asset tag inside an environment that is a sharing portal. Okay, so why is laser scanning important? I think we've touched on, that actually pre-procurement survey work, in my opinion, gets almost left to very much a sort of lastminute.com arrangement in a lot of environments. BIM gives us the opportunity to obviously realign where we're getting this data and what we're actually using the data for. Laser scanning is mainstream. I deal with, I'm covered the south of the UK and all of Ireland, north and south. We've got 2 of our customers here today. We've got Murphy Surveys and obviously Coastway as well, which was spoken about in the first presentation. Both of those companies have been very early adopters within the technology of laser scanning, and they are producing, and certainly Murphy's are producing some very high-end BIM-related deliverables from that. It isn't going to go away. It is a significant growth area. The hardware development has proved that we have this drive within the industry. And the laser scanning market, certainly in the UK, Leica is a global brand. The laser scanning market in the UK is the biggest, or the second biggest, only to North America. So we are a tiny little island, and we are driving where we're going with laser scanning technology. It is used in a lot of different applications. BIM is one of those, but I deal with customers within the forensics, crime, collision investigation, film industry, VFX industry, as well as obviously architects, engineers, and the multidisciplinaries. I'm going to very quickly now go back to that data set so I can show you very quickly what we've actually been able to capture. I'm inside Cyclone. Okay. And that is the point cloud data. So we can see in a 58-second scan just how much information we can capture. You know, yes, we are starting to look at larger file sizes, but what can we start doing this? And one of the very, very big shifts that we're actually seeing in the industry is the shift away from making point cloud data into things. So yes, in the early stages of a project, it is necessary to scan, capture accurately the environment that surrounds us so that we can have a very highly accurate, useful platform in which we can start to interrogate and design from. So yes, model by all means at that stage. When we start to move through the construction process where we're checking and we're verifying, laser scanning is increasingly being redeployed back onto site during the phases of development. So the slab is laid, rescan. Compare that scan data against the design model. Make sure it's in the right place, make sure it fits, make sure it's fit for purpose and within the error tolerances. After the steelwork goes in, again, go back, rescan, update, compare and contrast. And with this scan data, because it's so comprehensive, you don't need to make it into it's visually understandable. I mean, I'm looking in a nice clean 2D view because I'm looking straight out from the scanner's location, but I'm in full 3D. Okay, so one little scan, 12.5mm point spacing, took 58 seconds. The quickest scan that will do is 20 seconds. It's a bit patchy, it's 50mm by 50mm point spacing at 10 metres, but it would still give me an idea of what's going on. I did a couple of scans earlier on this morning. Okay, so again, one in this corner, one in the far corner. Yes, I'm in 3D, and also I've got an incredible amount of data that has captured beyond and out through the windows. So from just two very quick setups, I think I did 1 minute 44 setups when I did this. But the other really nice thing is we've got an onboard camera on the scanner. So I did actually take the images as well. Okay. So we've got photorealistic data. So from as-built, so we've moved through the construction process. So we've done our very, very accurate data capture to produce our existing scenario. We start the construction process, we update, we look at clash detections without having to do too much with the data. The human eye is fantastic. Usually if something looks wrong, it is wrong. So let's make things, let's not make the point cloud into something, let's use it in its pure form. Very, very quickly we can start to compare and contrast, analyse, look back at the model, see how the two are fitting together. And then obviously from an as-built perspective, once we've completed, before we hand over, we can start actually either adding asset information into here. So I can see within this room, I can see we've got fire, emergency light. So I can tag that emergency light and actually give it context, link it out to a database. You know, yes, the level of detail on it is reasonably coarse, but actually, all we need to know is visually be able to actually link in a model or a viewing portal that has an importance. Data points, switches, sockets, windows, you name it, it can all be linked and tagged. And we're seeing a big move to actually go towards now tagging information and populating and actually handing this over as, in effect, an accurate asset. Where there's a degree of question marks, which I feel that as a surveyor I start to wonder and question, is when we start looking at, this is very, very accurate data, but when we start modelling, you know, we've always been bounded by the RICS Code of Measuring Practice on how we should measure buildings and what are the, you know, as a surveyor we're all bound by scale, accuracy and precision and repeatability. So when we start to actually produce a traditional 1:100 floor plan, or 1:100 elevation, what are we looking at with regards to single point checking measurements? Soon as we start modelling, we are making assumptions. Now, packages that are on the market, such as Revit, they exist, they're brilliant, I'm an AutoCAD user. I've started to dip my toe into Revit, and what I've used and done with it, I am liking. But Revit likes verticals. It likes the horizontal planes. And we all know that in most buildings, the horizontals and verticals aren't necessarily true to life. The scanner will pick up everything, very indiscriminately as well. It will literally capture what it can see. But when we start to model that data and make it into something, we're then making another set of assumptions. So, survey company that I started with back in 1999, a company called Seven Partnership based in Shrewsbury in Shropshire. And they have recently undertaken a BIM project. They're one of the few survey firms who've actually started to employ not just surveyors, but they've actually gone down the route of employing architectural technicians. And they've recently undertaken a project with the RICS to scan Great George Street, which is our headquarters in Westminster. And they have made a full BIM model out of Great George Street. And they have scanned it, and they've taken scan to BIM. That's their big sort of strap line. But what they obviously, from an audience full of 100 surveyors starting to pick holes in scale, accuracy and precision, how they've dealt with an old building and producing a Revit model from that has a place and has a purpose. And I think they've actually handled it very well, because they've modelled within tolerances, and they've actually got a colour coding scheme on their model, on their Revit model, to show this wall has been modelled with an accuracy of plus or minus 2 mil. This wall has been modelled with an accuracy of plus or minus 5 mil. They've actually been able to categorise, and I think that's really, really important from us and the value perception of data, is that we can often get lost in translation. What that model or what that drawing was originally carried out for, and it can then get discredited. And I'm hoping that with this BIM process, that data doesn't get sort of lost along the way, that data enables you to work better, or sorry, that the point clouds enable you to work better and produce better deliverables as we move through the project. But we've got to be careful of making assumptions and where those assumptions have come from. And I think this has been a problem with survey drawings for many a year, and it's not something new, but I'm confident that because of what we're seeing and what we're doing with BIM, that the facility to be able to have this complete portfolio, data won't get lost, and it's a big, hopefully it's a big challenge that we can readdress specifications and how data is commissioned. And yeah, thank you. And hopefully realign the value part of what surveyors can offer the construction process. I'm going to come out of Cyclone. So this is in Cyclone very, very quickly. AutoCAD, so I'm just going to touch very, very quickly on putting data into AutoCAD. So AutoCAD 2014 or Autodesk Products 2014 and Bentley both run their own point cloud engines now. Before, this wasn't possible, so trying to load in millions of points within a point cloud into something like AutoCAD would basically make it fall over and cry. So we run our point cloud engine, which is Cyclone, and I'm just going to very quickly import in the room that I captured earlier on. It's not going to work now, is it? See, do a live presentation and it for some reason doesn't work. Apologise. Hopefully you've had an enjoyable couple of days, and I think for me it's great to be put in front of an audience where data is, I think, critical to everyone in this room, and the tools that we have available within hardware, software, etc. is quite exciting, because we have gone through this huge development process as a result of what's happening in the industry, and certainly it's quite exciting times ahead. And yeah, so I'm going to close off then, because I know I'm up against it time-wise. So if there are any questions, feel free to throw them at me.